So here's a couple things I want to go over about the review. Now this one I wrote at the top there, I was not in the review, but it's something that I want to make sure because this is not even something we went over here. This is like Algebra 1 we're talking about here. So I just want to, because I realize that a lot of people are struggling with something. So, and I just want to talk about it for a minute. I'm looking at this right here. If you don't have this, well, obviously you wouldn't because I'm just showing it to you now. Do me a favor and write this down like right up top somewhere. I want to show you a situation like this, which is way easier than people are making it. Like this is actually not a very difficult problem at all. It doesn't take much time, but let's talk about it. When we did those polynomial divisions, we had like a polynomial divided by another polynomial. This is not a polynomial divided by a polynomial. It is a polynomial divided by a monomial, divided by one thing, which is actually the easiest situation you can deal with because what we're going to do is we're going to take each thing on top, both of those things, and each one individually, we're going to divide it by what's on bottom. So here's what I'm going to look at first. Let me clear some of this up. First thing I'm going to do is I'm going to look at this. We've got this 14x to the fifth y, and I'm going to divide it by 2x to the third. Well, let's start with the numbers. What is 14 divided by 2? 7. That's 7. So our first number is 7. That part's done. Now here's a question. We've got x to the fifth divided by x to the third. What did we do when we multiplied two x's together? We added, but now we're about to divide these two things. So what do you think we do with their exponents? We're going to subtract them. So what is 5 minus 3? This ends up as x squared. X to the fifth divided by x to the third is the same thing as x to the 5 minus 3. And this y right here has nothing to divide with, so it just stays there as a y. Now I'm going to do the same thing for that other thing there, this negative 6x to the third y squared. What is negative 6 divided by 2? It's a negative 3. Now what is x to the third divided by x to the third? It's going to be x to the 0, which equals 1. And then that y squared has nothing to divide with. Now, I don't really like this answer because of one thing. One thing is bothering me up there. Let's just multiply this, and what does that become? It's just negative 3y squared. So we get 7x squared y minus 3y squared. We didn't need all that polynomial long division and the synthetic division. Now, here's the questions that you'll probably want to know. Tomorrow's test does have questions that tell you to divide using long division, and it has other questions that you need to divide using synthetic division. Whatever it asks for, that is how you need to divide them. If I don't see that work, even if the answer is right, I'm not going to give you credit for it. So even if 100% of your answer is right, I'm not going to give you credit for that unless you did it the way that was asked for. So I just want that to be out there because I don't want anyone to freak out about that later. You can still check it with synthetic division to make sure you're right, but I need to see the long division on those because I'm guessing most people are going to go to synthetic division first. All right. Take a moment and look at the answers for 5 through 8. If you didn't actually do it, I'm going to post this later, so you don't need to start taking pictures. I'm going to post this video. I'm going to post the actual solutions up there, so you don't need to spend all your time taking pictures. Just pay attention if you didn't do it. I mean, like if you're not doing the work ahead of time, don't try to cram it in with a whole bunch of pictures. It's not going to happen. Let's look at number 5 for a moment. I'm going to zoom in on number 5. Why, when I look at this, like looking at this, the initial problem we started at, why is the leading coefficient not 4? Because 4 is the number that's out front, so why is it not 4?
Because it's squared, not cubed.
Notice that when we write these, we have to write them in standard form, which means the highest degree goes first. The highest degree is that negative 3x to the third, followed by a positive 4x squared, followed by a positive 6x, followed by positive 7. That is why the leading coefficient is negative 3. The number, not the x part, just the number that is out in front there. Now, some of you, when I asked you for a degree, were giving me the names. A degree is just the number. It is the highest exponent that I see up there. The highest exponent that I see up there is a 3. Let me show you something else that didn't go very smooth on the quiz. Let's pretend I had something like this. What is the degree of that monomial? You guys can throw it out there, it's all right. It's 7. And it's 7 because we take the two exponents of this one term, there's just one term there, and we add them together. So if that is 7, think for a moment, we know that this degree is 7. I'm going to put a little note up there. Plus 3x to the 4th, y to the 4th, minus 2x squared, y squared. What is the degree of this polynomial? Take a moment.
8.
Why 8?
Because 3x to the 4th and y to the 4th, 4 plus 4 is 8.
Remember, the highest degree here is 8. Some of you weren't doing that on the quiz. You were skipping that step there, and you were just saying, oh, I saw a 5 there. 5 is the highest number. It must be 5. 5 isn't even a degree of anything up there. 7 is, 8 is, and 4 is. The highest degree, though, is 8. So on this one, when we did it, we just looked for the highest degree, but these are a little easier. The number of terms, remember, if you want to know how many terms there are, circle the pluses and the minuses. However many things there are in between them, that's how many terms there are. 1, 2, 3, 4 terms. Then we get to the naming part. And again, this area was a little bit rough because some people didn't know that chart. They knew the degree was 3. They didn't know what the name for that was. That's a cubic. So this is a polynomial that is cubic. Because it has 4 terms, we call it polynomial. A cubic polynomial. The number of terms decides this name. The degree decides the first name. So any questions on 5 through 8? Because those are all basically the same types of problems. We do them all the same. You must put them in standard form before you can start answering these. Again, the leading coefficient is the number out front when they're in standard form. The degree is the highest degree that you see. The number of terms, how many different things are being added and subtracted together. And then you just got to know that chart for the names. Any questions 5 through 8? All right, moving down. 9 through 12. I'm actually going to do 12 first because I think it's one of the easier ones. When you are just adding two things, and I know it's adding because I see that there's a parentheses plus another parentheses. It's the first parentheses plus the second parentheses. I am just going to add them. I don't need to change any of the signs. It just means we're just going to add this plus this plus this plus this plus this plus this plus this. So that's why you see those same things right down here. They didn't change. They're all the exact same. So when we add them, we put we put all the common terms together. We've got x to the 4th minus 5x to the 4th to get me negative 4x to the 4th. Then we've got a negative x to the 3rd, which can't combine anything. Our x squared canceled out with a negative x squared. And then we get positive 4 minus 7, which gave me negative 3, leaving me with negative x to the 4th minus x to the 3rd minus 3. The addition ones aren't so bad. It's the subtraction ones that are getting you guys. And here's why. When you subtract, you have to distribute that negative to each one of these things here. So notice that the 1 became a negative 1. The negative 5x squared became a positive 5x squared. The positive x became a negative x. Why? Because that negative switched all of them. Negative 1 times 1 is negative 1. Negative 1 times negative 5x squared is positive 5x squared. Negative 1 times x is negative x, in which case just add them all together after that. Questions on 9, 10, 11, or 12? Okay. All right, next up we get to the multiplication. Real quick, a reminder is that when you are adding or subtracting, the exponents do not change. Like an x squared is not going to change into an x to the third power or something less. But when you multiply, exponents will change. So when we multiply, we're just distributing. Remember when we distribute, 5 times 3 gives me the 15. And the x squared times x, that's the same thing as x squared times x to the first becomes x to the 2 plus 1 becomes x to the third power. That's where we get this 15x to the third power. We distribute the 15x times 15x, rough day, 5x squared times negative 2 gives me negative 10x squared. Questions on 17 through 21. I'll put the answers up there so you can see them. I crossed out this one right there because it was written in the wrong order and there was a little mistake in there, so that mistake has been corrected. I will post these again. This will be posted for you. You'll get to go through and you'll have them. I'll put it in the announcements as a PDF. You'll have the video, so you'll have all those things to look through. Only through 21, because 22 is different. 22 is the one that people don't like. All right, let's go to 22 then. Nope, wait. Okay, I'm waiting. Yep, I'm waiting. Okay, let's look at 22 and 24, because 22 and 24 are the exact same type. So I'm going to do one of them because if I can do one, then I should be able to do them all. I'm going to do 24 because 24 is the harder of the two. 22 is easy compared to 24. So 24, I need to raise this to the fourth power. How can I do that? What method can I use? Yes, sir. Pascal's triangle. Let's construct Pascal's triangle. What do I start with? A triangle made out of ones. And then what line comes next? 1, 2, 1. So this is going to give me, if I'm solving for the 0 power, I use that. If I'm solving for the first power, I need that. Second power, that. So I need to keep going. What's my next line? That's for the third power. And I need the fourth power, so I need one more. 1, 4, 6, 4, 1. Bravo. Okay, so that's where this 1, 4, 6, 4, 1 came from. Now remember that the 2x is going to be raised to a power. That's why you see 2x, 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 2x. And the positive 1 will be raised to different powers. So when I do the 2x, I start with 2x to the fourth power, third power, second power, first power, 0 power. Why did I start with 4? Why not another number? Why did I use 4?
Because it's raised to the fourth power.
Because it is to the fourth power. That's why I chose it. This was the fourth power. If that had been the sixth power, I would have started with 6. If it had been the 12th power, I would have started with 12. When I do the second term, the one on the right, I start at 0 and make my way up. 0, 1, 2, 3, 4. All right. So let's talk about these ones on the bottom. All of those ones, what is 1 to the 0 power?
1.
That's going to be 1. What is 1 to the first power?
1.
1 to the second power? 1 to the third power? 1 to the fourth power? It's just going to end up as 1. So no matter what, this is all going to be multiplied by 1. That's not really going to make a difference. When you multiply something by 1, it doesn't change it. The big difference is going to come is when I multiply these things times these things. And the big problem comes on the second line. This means that the 2 needs to be raised to the fourth power and the x needs to be raised to the fourth power. What is 2 to the fourth power? 2 times 2 times 2 times 2. 16. 2 times 2 is 4, times another 2 times is 8, times another 2 is 16. That is where this 16 came from right there. And then we've got x to the fourth power. On this next one, we've got 4 times, well, the 2 gets raised to the third power. 2 times 2 times 2 is? 8. And then we've got x times x times x, which is x to the third power. That's where this part came from, and the 4 came from right there. 4 times 8 gives me 32. That gives me 32x cubed. Moving on to the next one. 2 squared is 4. X to the second power is x squared, and that is going to be times 6. So we get 6 times 4x squared becomes 24x squared. Here we've got 4 times 1 times 2, 2 to the first power is 2, and x to the first power is x. So that's where 2 to the first power is 2, x to the first power is x. Times that 4 that was up top gives me 8x. And this last one is just 1 times 1, which is 1. All of that simplifies to this right here. Yes, sir?
If it wasn't plus 1, if it was like plus 5, would you multiply everything times 5?
It would be 5 to the first power, 5 to the second power, 5 to the third power. It was only because this was a 1 that made that easy. If that had been any other number in the world, it wouldn't have been easy. It would have been like, 3 to the second power, 3 to the third power, 3 to the fourth power. It just would have got like different numbers.
It would just been along the
Right, because when you multiply by 1, it doesn't change anything, right? It's when we, if we multiply all these things times 1, like this times 1, this times 1, this times 1, it's not going to change the answers.
But if it was 5, we'd have to multiply that.
Yeah, you'd have to multiply them all by 5 or 25 or 125, whatever the number is.
Do you think we're going to have something like that on the test?
For sure, you'll have to do Pascal's triangle on the test. No doubt.
So
Yes, sir.
for the middle part,
The green part?
the green part, yeah. The
Yep.
green part, we multiply with the outside, and then
Like for this 4 times 8, that's
bring down the top numbers next to it.
right. So here's where the 4 came from. There's the 4. Now, where did the 8 come from? That's 2 cubed. 2 times 2 times 2. That's where the 8 came from. Where did the x to the third power come from? Right there, x times x times x. And then we had 4 times 8x cubed times 1. Well, the 1 doesn't do anything, right? Times 1 doesn't do anything. But 4 times 8x cubed becomes 32x cubed. 4 times 8 is 32, and then you just stick the x cubed right on there. You're welcome. All right, I want to do one of these questions with long division and definitely one with synthetic division. So let's do 27. Something has changed between this and this. Yeah, so what changed?
Because it wasn't in standard, because there was no x to the third.
We were missing an x to the third power here. We didn't have it up there. So we had to add it in. And you're allowed to put in x to the third powers as long as you're only putting in 0 of them. Because if you put in 0, that doesn't change anything. If I said, hey, can I have some of your pizza? And you say, yeah, you can have 0 pieces of my pizza. That's what we're talking about there. None of those. So that's where this 0x to the third came from. Now here's how it all works. I'm going to just erase this and work this through. I'm going to try to do this a little bit faster now because most of you have gotten pretty good at it. Okay, it's running a little slow, so I'm going to just redo this off to the side here. Let's just do a new one here. We've got 8x to the fourth plus 0x cubed plus 6x squared minus 2x plus 4 divided by, what is going on here? Divided by 2x minus 1. The first thing that we're going to do is say 2x times what will give me 8x to the fourth? 4x. Sorry, this is having some issues writing all of a sudden. 4x to the third. 4x to the third times 2x is 8x to the fourth. And 4x to the third times negative 1 is negative 4x to the third. I'm going to subtract those. 8x to the fourth minus 8x to the fourth is 0. And 0 minus negative 4x to the third is actually a positive 4x to the third, because when you are subtracting a negative 4x to the third, that becomes pluses. Bring down the 6x squared. 2x times what would give me 4x cubed?
Maybe 2x to the second.
2x squared times 2x will give me 4x cubed. And 2x squared times negative 1 is negative 2x squared. 4x cubed minus 4x cubed is 0. And 6x squared minus, so 6x squared minus a negative 2x squared, that becomes 8x squared. Bring down the negative 2x. 2x goes into 8x squared how many times?
Maybe twice.
Sorry, I jumped to the wrong one there. 4x. 2x times 4x would give me 8x squared. 4x times negative 1 is negative 4x. And if we do negative 2x minus a negative 4x,
How'd you get 8x? Wouldn't it be 4x because 6x to the second minus 2x? Oh, okay.
so we get 8x squared minus 8x squared is 0. And then negative 2x plus 4x is 2x. Bring down the 4. 2x goes into 2x one time. 1 times 2x is 2x. And 1 times negative 1 is negative 1. We are nearing the finish line here. We've got 2x minus 2x is 0. And 4 minus negative 1 gives me 5. So our final answer is 4x cubed plus 2x squared plus 4x plus 1. What is my remainder? 5? Just 5?
So it would be 5 over 2x.
2x minus 1. Oh, what just happened? Okay, last but not least, we've got the ones with synthetic division. Now in here, we'd done them out with long division, so I'm going to actually redo them here. So we've got, let's do 29. I'm just going to redo it. The answers are already right here, but I'm going to redo it just so that we can all see how to do it. We had x to the third power plus 2x minus 1 divided by x minus 2. Using synthetic division, first of all, is anything missing?
0x squared.
Yeah, we need a 0x squared because it's missing there. So let's make our backwards L. What number goes in the backwards L? A positive 2. What numbers go next to it? 1, 0, 2, negative 1. This is why synthetic is so much faster. What do I do with that first 1? Bring it down. What is 2 times 1? 0 plus 2. 2 times 2. 2 plus 4. And 2 times 6. What is negative 1 plus 12? All right. Now what do I do to translate this answer into English now?
It would be 6x to the 0 power, then 2x to the first power, and 4x to the second power.
What about that 11?
It's a remainder.
It's the remainder. So we have an x squared plus 2x plus 6. And how do I write the remainder?
Plus 11 over x minus 2.
Perfect. So I'm going to post the video. I'm going to post the actual solutions there so you can look through those as well. But this is what we are looking at there. So if you've got something that you are not strong at, maybe that means that you are watching the videos tonight and getting the hang of it and doing the sample problems, because some of you are not practicing them, so it's very difficult for you to get them.